Now we are going to solve the problem 4.4 in chapter 4. It is given in page number 171. First I will read the problem. If an object of mass 2 kg, the mass of the object is 2 kg. The mass is given. Okay, it is thrown up from the ground. It is thrown up from the ground level and reaches the height of 5 meter. It reaches the height of 5 meter. After that, after reaching that point, again it falls back to the earth and the air resistance to be neglected. You are asked to calculate the work done by the gravity when the object reaches 5 meter height. You are asked to calculate the work done by the gravitational force after reaching the height of 5 meter. So we have to consider the upward motion. Are you clear? And two more questions are also asked in the question. First, we'll solve the first part. The work done by the gravity when the object reaches the 5 meter height. That is to be found out now. Here, displacement, when it moves from here to there, the displacement is to be taken as dr. The dr value is 5 meter. Are you clear? The mass is given. The mass of the object is 2 kg. Are you clear? When the object goes in the upward direction, the gravitational force is acting in the downward direction. Are you clear? So whenever any body goes up, the gravitational force, it pulls the object towards downward direction. Therefore, the most important thing is when the object is moving in the upward direction, displacement that takes place in the upward direction, gravitational force is acting in the downward direction. Therefore, the angle between the gravitational force and the displacement is theta is equal to 180 degree. Are you clear? This one is acting in the downward direction, gravitational force. The body moves in the upward direction, displacement is in the upward direction. The angle between the force and the which one? This displacement is how much? 180 degree. This is most important one. Here, how to calculate the work done? What is the formula to calculate the work done? Work done is clear by the gravitational force. That is very important. Are you clear? Body moves in the upward direction. No, work is done by the gravitational force in the upward motion to be calculated. The basic fundamental formula is F into dr cos theta. Are you clear? This is the very fundamental formula. Are you clear? Now what we have to do, which kind of force is acting? Gravitational force is acting. To calculate the gravitational force acting on the body, what is the formula? Mg is the formula. Instead of F, you substitute mg, dr is the displacement. So clear, and we know the value of theta, that is angle between F and dr is 180 degree. Are you clear? In the next step, we can substitute m into g into dr instead of cos 180. Cos 180 value is -1. Are you clear? And then substitute the value of mass. The mass of the object is 2 kg and the g value is roughly taken as 10 meter per second square. Are you clear? Displacement, when it goes from here to there, the displacement is 5 meter. Are you clear? After substituting all the value, you will get minus 100 joule. Are you clear? Minus 100 joule, it shows that the gravitational force, it does the negative work. Are you clear? It shows that object moves in the upward direction, no, against to the motion of the object, against to the movement of the upward motion of the object, gravitational force, it does the negative work. Are you clear? It is not allowing the body to go up. It shows that the gravitational force is doing negative work. Therefore, we have calculated the gravitational force, work done by the gravitational force when the object moves in the upward direction. Very interesting one. Note down this, the work done is negative here. Work is done by the gravitational force, that should be considered as a negative work. That's why we have got the answer as minus 100 joule. Understood? In the second part of the question, what is asked? Work done by the gravity when the object comes back to the earth. Are you clear? The work done by the gravitational force when the object is coming towards downward direction to be calculated. The formula, how it should be written? Work done by the gravity when the object goes towards downward direction. W down must be written. Again, the formula is F into dr cos theta is the fundamental formula to calculate the work done. Here the displacement, that one takes place in the downward direction. Object is moving towards downward direction, and the gravitational force acting on the body is also acting in the downward direction. Both gravitational force and the displacement both are taking place in the same direction. Therefore, the angle between gravitational force and displacement is 0. Are you clear? 0 degree. Therefore, substitute the values in the formula. Already we know very well that the force, nature of the force is gravitational force. Therefore, instead of F, we can substitute mg and then dr to be substituted displacement. After that, instead of cos theta, cos 0 to be substituted, because angle between the gravitational force and displacement, since both are acting in the same direction, angle is 0, theta is 0 between F and dr. Cos 0 value is 1, and substitute the value of mass. The mass of the object is 2 kg and the g value is roughly taken as 10. Displacement is 5 meter. Cos 0 value is 1. Are you clear? After substitution, you will get the answer as 100 joule. Here the work is said to be positive. So work done by the gravitational force when the object moves in the downward direction is how much? 100 joule. Very simple problem. Are you clear? So what is the final question is asked? Total work done by the gravity both in upward and downward motion to be calculated. Total work done to be calculated. Total work done by the gravity both in upward and downward motion, and mention the physical significance of the result is asked. That is very important. Are you clear? How to calculate the total work done? Very simple. Are you clear? To calculate the total work done, what we have to do? Look at here. Total work done. Substitute the values. Are you clear? Total work done is a formula for which, what is the formula required? Work done by the gravitational force when the object moves in the upward direction, work done by the gravitational force when the object moves in the downward direction, both of them to be added. Clear? The object goes up, by the time gravity does some work. When the same object comes down, now also gravity does some work down. Okay. So work done in the upward motion, work done in the downward motion by gravity, both of them to be added. Are you clear? We know the value of the work done when the object goes in the upward direction. How much? Minus 100 joule. Already calculated. Here we have calculated plus 100 joule. Are you clear? After substitution, if both are added, you will get 0 joule. Are you clear? Finally, the answer what is obtained is, are you clear? Gravity does not do any work. Are you clear? Gravity, it does not do any work here. Are you clear? Gravity does not transfer any energy. The total work done by the gravity is 0, 0 joule. Gravity does not transfer any energy to the object. When the object is thrown upwards, the energy is transferred the object to the object by the external agency. Are you clear? Isn't it? When you throw up, you are supplying the energy. Are you clear? So when you throw any object, you are supplying energy. With the help of that energy, it goes up. Can you understand the point? When the object is thrown up, the energy is transferred to the object by the external agency, which means that the object gains some energy. If you supply energy to the object, that object will gain some energy. As soon as it comes back and hits the earth, the energy gained by the object and it is transferred to the surface of the earth. Are you clear? When it is coming back, the energy stored up will be completely dissipated here. Are you clear? That one will be transferred to the earth. Are you clear? The very important thing is the conclusion is finally the total work done by the gravity is 0. Again, I will repeat. To throw the object, you have to supply the energy. You are the external agency. With the help of your energy, it goes up. Are you clear? After that, the energy is stored up here. That energy will be again transferred to the earth. So ultimately, the total work done by the gravity is 0. Are you clear? The conclusion must be written. Understood?